Welcome and hello. This is a video tutorial on HEC ResSim, and in this lesson I'm going to describe the reach editor. What I have on the screen here is a reservoir network, and you're seeing junctions, reaches, there's a reservoir as well. This was actually created from a watershed setup in the watershed setup module with computation points and stream alignments and so on. So anyway, if you're following along, go ahead and create your reservoir network. And then now we're ready to add some reach data. So to make edits to the reach, what you're going to do is click on the reach tool here on the left tools menu, and then right click the reach. And we have edit reach properties. There's also rename reach, break reach, delete reach, and import properties. In this video, I'm going to talk about the edit reach properties dialog box and what we can do here to edit the reach. But I did want to mention that renaming the reach is an option. These are just some more simple edits. Breaking the reach, that's if you happen to have one reach, but you want to split it into two reaches. That will also define a new junction point. You can delete the reach and import some properties. So edit reach properties dialog box is right here. And you can also bring that up by clicking edit in the top menu and then reaches. It's the same thing. Also, from the previous video of junctions, I forgot to mention you can open the junction editor by going edit junctions. So that's for junctions. But this video is about reaches, so we'll just right click, edit reach properties, and these are our properties. We have reach 2-3 selected. That's just what I'm calling this reach because it's between junctions CP2 and CP3. But we can edit this reach by going right click, edit reach. Again, we can also change it here, as well as toggle between the different reaches using these arrows. The description is also important. Now, in these video tutorials, I've been skipping over the description, but I just wanted to make a point, as the user manual mentions, that the description really is important for documenting what you're doing. It's good for communication to describe what in the model it's actually modeling in the real world, especially if there's many different people working on the project. So now that we have our reach that we're editing, we have three different tabs. It's routing, losses, and observed data. So first I'm going to talk about routing. What the routing tab does is it describes how the flow moves through that reach. The default routing method here is null, but as you notice, there's a number of different routing methods ResSim supports. Null is the default routing method. It requires no parameters, which is why we're not seeing any required fields once null is selected. And it represents no lag or no attenuation. So whatever flow enters the reach instantaneously exits the reach. It's just that simple. Okay, so a couple of the other routing methods I wanted to describe in this video, some of the more common ones are the coefficient routing. Now, coefficient routing involves time steps and coefficients. And these coefficients represent the percent of flow from the current or previous time steps of flow entering that reach to calculate the flow exiting that reach. So what that looks like in the model would be the sum of these coefficients have to equal 1. So if we just had a 1 here in the first time step, this would effectively be the same thing as null routing, where everything that enters also exits. But the user manual provides an example where time step 1 is 0.75, and then time step 2 is 0.25. That sums up to 1. So the outflow from that reach would equal 75% of the inflow from that reach in that time period, plus 25% of the inflow from that reach in the previous time period. And then the outflow would continue to calculate each time period using this breakdown, the 0.75 and 0.25, if that makes sense. So anyway, the user's manual does a great job with equations and explanations. So I'm just going to refer you folks to checking that out for any extra details that may not be obvious from my description here in this video. The next routing coefficient is also a popular one. It's called the Muskingum routing method. There's a couple coefficients here. The Muskingum K represents the duration it takes a droplet of water that enters the reach to exit the reach on the downstream end. So that could obviously depend on the reach parameters, such as the length of the reach, the flow rate, and cross-sectional area, or you could just say average velocity. And keep in mind, these are all linear um, approximations, or not all of them, but like the coefficient routing is linear, the Muskingum is linear. So we are creating a linear approximation of a non-linear reality. So we need to keep that in mind. And if we have to make our reaches smaller for more precise numbers, then, so be it. But anyway, let's go ahead and just type in some numbers. Maybe it takes 2 hours for a droplet of water to traverse this particular reach, 2-3. And then Muskingum X represents the um, attenuation coefficient. So 0 is the minimum value and 0.5 is the maximum value. Again, the equations for all this are in the user's manual, but if it's 0, that represents maximum attenuation, where storage is entirely dependent on the outflow. And then 0.5 would be the minimum attenuation, where the storage in that reach depends equally on inflow and outflow. So we could just, I don't know, say 0.25 is kind of a middle ground number there. And the number of subreaches depends on the Muskingum K. One rule of thumb here is that a droplet of water should take at least as much time as the time step in the simulation when traveling through a reach or a subreach in this situation. So say we have a 10-minute time step in our simulation, and if we have a 2-hour Muskingum K value, then 10 minutes goes into 2 hours 12 times. So in that case, we would put a 12 here. So when setting up that subreach number, we have to sort of think ahead to our simulation and the time step, as well as this Muskingum K coefficient. Okay, so what you're seeing here are other routing methods. I'm not going to talk about any more in this video, but the user's manual does do a good job describing them. As you can see, when you click on the different routing methods, there's more inputs, it's more precise, and yeah, there's just more math involved. So go ahead and check that out. Ultimately, you're going to use the routing method that already exists in the model that you're working on. Maybe that's up to the client or maybe the company. So there's really no need to become an expert on all 9 routing methods or however many there are. Just become an expert and fully understand the routing method that you're using for your model. All right, so the next tab over here in the Reach Editor dialog box is for losses, and this refers to seepage in the reach. You can type in a constant seepage, which may be satisfactory if there's not much variability based on the flow. But if the seepage in the reach does vary a lot with the flow, then you can go ahead and click the second option, which is seepage as a function of flow, and then type in your numbers, and then you get a small little graph out here to the right. So I'm going to do that real quick just so you can kind of see what that looks like. Okay, so there's a typical graph. I just made up these numbers, so that's not necessarily realistic, but you can kind of see what that seepage versus flow curve looks like. All right, the last tab here in the Reach Editor dialog box is for observed data. We saw this with the Junction Editor, where if you have observed data that you want to put into your alternative editor, you can go ahead and click this checkbox and then click Apply, click OK, and then once we go ahead and create an alternative, and I'm not going to create an alternative, I'm just going to show you what it looks like. There's a number of tabs here along the top, and if we click Observe Data, now we have a record in the table to provide flow data, time series data, representing the flow in Reach 2.3, which is the one that we were editing and the one that we put the checkbox in back in the Reach Editor dialog box. So that's it for this video. I'm not going to save the alternative, but we talked about the different properties and the ways to edit the reach using the Reach Editor dialog box, routing, losses, and observed data.